Okay, Trig kids, this is section 7.5. I'm going to try to see if we can get this all done in one video. There's a total of just 9 problems, so let's get busy. This section, we are solving trig equations. Okay, so the idea is to isolate a trig function and then solve it. So my first problem is 2 times sine squared theta plus cosine theta equals 1. Now, in order to get everything in terms of the same trig function, I'm going to substitute our trig identity. Let me remind you of that again. Okay, trig identity, remember, is sine squared plus cosine squared equals 1. So I'm going to substitute in here for the sine squared. I'm going to substitute 1 minus cosine squared. Okay, so then the rest of my equation looks like this. So then if I distribute, I have 2 minus 2 cosine squared plus cosine theta equals 1. Okay, then subtract your 1, pull it over. Well, actually, I'm going to move everything over to the other side so that my cosine squared is going to give me 0. So 0 equals 2 cosine squared theta minus cosine theta minus 1. Okay, so I just moved everything over to the other side so that my leading term, my cosine squared term, would be positive and everything's together. Now, we can factor this. We did some of this in the last section, so we can factor this. We've got 2 cosine theta for one of my binomials. The other one's going to just start with a single cosine theta, looking for factors of -1 here, and it's going to add to a -1 in the middle. So this is going to have to be the +1. That's got to be the -1. I'm going to move the 0 over to the other side now because that's where we're used to seeing it. So now remember, this is going to split out that 0 product principle into 2 separate equations. I'm going to have 2 cosine theta plus 1 equals 0, and I'm going to have cosine theta minus 1 equals 0. Well, this one's going to give me cosine theta equals -1/2. This one is going to give me cosine theta equals 1. Now, I have to solve each one of those. Okay, so if you look at your unit circle that we've always got figured out here, if you remember, cosine is negative. Remember, cosine is your x-axis, so it's negative in the second and third quadrant. Second and third quadrant is where cosine is negative. So this is going to give me 2 answers. And again, we have to use those cyclical answers with the 2 pi k because we have to account for every possible solution. So this is going to be 2 pi over 3 plus 2 pi k. That's one of my answers. In the third quadrant, it's going to be 4 pi over 3 plus 2 pi k. Okay. And then where cosine equals 1, remember again, that is essentially 0 plus 2 pi k. So it's just 2 pi k, because 0 is when cosine equals +1. Okay, at 0 degrees or 2 pi degrees or 4 pi or 6 pi or whatever. So those are your 3 answers. Okay, next one. I've got 4 sine of 2 theta minus 2 times sine theta equals 0. Now, I have got to get rid of the sine of 2 theta. Okay, so I'm actually going to use one of our double angle formulas. If you remember double angle formula, one of our formulas, I'll put it over here, was that sine of 2x equals 2 times sine x cosine x. That's one of the formulas on the Trig cheat sheet or in your PowerPoint for this section. So I'm actually going to substitute that in. I cannot solve an equation where one of the trig terms is in terms of 2 theta and one of them is in terms of a single theta. Got to have them the same. So I am substituting in here 2 sine theta cosine theta. Okay, so I'm substituting that in. Now, this is going to give me 8 sine theta cosine theta minus 2 sine theta. Now, factor out the GCF. My GCF here, both terms, this is a term and this is a term. Both terms have a 2 and a sine theta in them. So if I factor out the 2 sine theta, what's left is 4 cosine theta minus 1 equals 0. Okay, so now again, I've got two things multiplied together to equal 0, so I have to set them each equal to 0. So this gives me 2 sine theta equals 0, and it gives me 4 cosine theta minus 1 equals 0. Got to solve each of those. So divide by 2, obviously sine theta equals 0. Now, sine theta equals 0 at 0 or pi. So it's every pi. So essentially it's 0 plus pi k, which is then just pi k. Again, sine, remember, is your y-axis. So it is a 0 at 0 and pi, 0 pi, 0 pi, or 0 pi, 2 pi, 3 pi, 4 pi. So any pi times k. And then this one over here is going to give us cosine theta equals 1/4. That one we're going to have to just poke in a calculator, but we need to remember that cosine is positive. Let me get over the dead spots here on my board. Cosine is positive in the first quadrant and the fourth quadrant. Okay, so the first quadrant, if you poke arc cosine, if you put in arc cosine of 1/4 in your calculator, make sure you're in radian mode, okay, not degree mode, but you should get 1.318. And again, this is plus 2 pi k. So that is one of your options, okay, one of your answers, I should say. Now, in the fourth quadrant, again, if you picture your unit circle, if this is 1.318, then this down here would be a negative 1.318, or 2 pi minus 1.318, which is going to give us 4.965 plus 2 pi k. Again, it's cyclical. Happens every fourth quadrant. So those would be my 3 answers for this one. And again, in your answer box, just separate them by commas. Okay. Next one, number 3. I have tangent theta minus 3 cotangent theta equals 0. Now, couple of different ways you can do this. I ended up rewriting this by taking cotangent as 1 over tangent. So again, there were a couple of different methods. Remember, cotangent is the inverse of tangent, so it's 1 over tangent. So I rewrote it that way. Then If you think about it in terms of multiplying every term by a tangent theta, okay? If you multiply every term by a tangent theta, this is going to give you tan squared theta minus 3 equals 0. Okay? Now, this is going to give us tan squared theta equals 3. Now, to solve for the square, remember we got to square root both sides. And what happens when we square root both sides? Don't forget, you've got to have a plus minus. Okay? So, this is going to make tangent theta equal plus or minus root 3. Now, that means it's going to happen in essentially every quadrant. Tangent, if you remember, is positive in the first, negative in the second. Positive in the third, negative in the fourth. So really, we only need to find them in the first 2 quadrants. Okay? So, let's just do first quadrant and second quadrant. Again, that's one of my dead spots. Let me scroll up a little bit here. Now, first quadrant. Again, if you look at your unit circle, this gives you in the first quadrant pi over 3. And instead of plus 2 pi k, remember the period for your tangent function is just 1 pi. So it would just be plus pi k, not 2 pi k, just pi k because it's tangent. And that's going to repeat from the first quadrant to the third, back to the first, back to the third. Second quadrant, your answer is going to be 2 pi over 3, and again, plus pi k. Again, the domain, if you will, or of your period, I should say, of your tangent function is 1 pi. So in the second quadrant, it's going to repeat second, fourth, second, fourth. So those are your 2 answers. Okay, next problem. I have 3 tangent theta plus secant squared theta equals 5. Now, this brings up another trig identity. Up till now, the main trig identity we've been using has been sine squared plus cosine squared equals 1. There's another one. And again, this is on your cheat sheet, and it was also in one of your PowerPoints. But another trig identity is that tangent squared theta plus 1 equals secant squared theta. Now, I'm not so sure. We might have actually proven that back in a previous section. I don't remember. But that's another trig identity. It's not as well known or as well used as the Pythagorean theorem, the sine squared plus cosine squared equals 1. But tangent squared plus 1 equals secant squared. So we are going to substitute that in. This is going to be tangent squared theta plus 1. So the rest of this equation stays the way it is. Okay. Then I'm going to pull the 5 over and rearrange it a little bit here. So we're going to have tangent squared theta plus 3 tangent theta minus 4 equals 0. Okay. Now, this will factor. Okay. So if we factor here, we've got both binomials starting with a tan theta. Factors of negative 4 that add to positive 3, excuse me, are going to be a plus 4 and a minus 1. Okay, so now we have 2 equations. We have tangent theta equals negative 4. I kind of skipped ahead. And then this one's going to give us tangent theta equals 1. Okay, so on tangent theta equals -4. Let's take a look at it first. Again, remember tangent is negative in the second and fourth quadrants. So I'm just going to find, well, there's a couple different ways you can do this. Actually, if you poke that in a calculator, I believe it's going to give it to you in the fourth quadrant. So we'll just use that. So this gives us the answer -1.326 plus pi k. Again, 1 pi k, not 2 pi k, because the period of tangent is just a single pi. So that's actually out of the fourth quadrant. Okay, and tangent theta equals 1. That is going to be pi over 4. That's from the first quadrant. Okay, and again, plus pi k. It cycles. Okay, so those are the two answers. Okay, let's keep going. Number 5. I have tangent theta plus 1 equals secant theta. Now, I got to get all of these in terms of the same trig function. So here's what I'm going to do. I am going to square both sides. And when I square both sides, then I'm going to use the trig identity that we just learned on the secant squared to get everything in terms of tangent. But we have to be careful because when we square both sides of an equation in order to solve it, if you remember, when you take something to a higher power in order to solve, you could potentially be adding extraneous solutions. So once you solve for this, then at the very end, we're going to have to check our answer to make sure they fit. Okay, so on the left-hand side, I'm not going to work it out per se. You all can, FOIL out tan theta plus 1 times tan theta plus 1, but you're going to get tan squared theta plus 2 tan theta plus 1 equals secant squared theta. Now, in place of secant squared theta, remember, okay, secant squared theta we can substitute as tan squared theta plus 1. That's one of the trig identities. So now, this is what we have. Okay, well, what's nice here is that my 1's are going to cancel on either side. My tan squared thetas are going to cancel on either side. All I'm left with then is that 2 tan theta equals 0. So that means tan theta equals 0. Well, we have to check for extraneous solutions here. Theta could be 0 or it could be pi. Okay? Theta could be 0 or theta could equal pi. Okay, because remember, tangent is sine over cosine. So tangent is going to be 0 whenever sine is 0. And sine is 0 at 0 and pi. So here's the trick though. At 0, if we plug it in, this would be, of course, 0 plus 2 pi k. But if we check it, if we go back to our original equation, do I get tan of 0 plus 1 equals secant of 0? Well, tan of 0 is 0 plus 1 equals secant of 0 is 1. So 1 equals 1. This works. That's one of my answers. Okay, now what about pi? So if this is an answer, again, my answer is going to be pi plus 2 pi k. Okay, so let's check it. So if we check, we are asking ourselves if tangent of pi plus 1, does that equal, I should have put a question mark over here too, does that equal secant pi? Well, tangent pi is of course 0 plus 1, so I'm going to get a 1 here on the left-hand side. Secant of pi, however, remember secant is 1 over cosine, and cosine is going to give us a -1. So this one does not work. This one does. And that's also why, if both of them worked, we could have written the answer as just pi k, because it would have just cycled every pi. But it doesn't, because again, we had to check for extraneous solutions. And the reason we had to check for extraneous solutions was simply because we had to square it in order to solve. Okay? So I hope that makes sense to you. Okay, moving right along. Next one is my number 6. We have 2 sine of 2 theta equals 1. Now, if I solve it the way it is, okay, then sine of 2 theta equals 1/2. Now, when does sine equal 1/2? Okay, so what we're asking here is, when does sine equal 1/2? That is pi over 6 or 5 pi over 6. In quadrant 1 and quadrant 2 is where sine is positive. Okay. First quadrant and second quadrant is where sine is positive. So this would either be pi over 6 plus 2 pi k, or 5 pi over 6 plus 2 pi k. Now, here's the deal though. This wasn't solving for theta, this was solving for 2 theta. Okay? This was 2 theta equals this or this. So how do I just get 1 theta? I actually have to come in here and divide everything by 2 to solve for 1 theta. Okay, because what I actually solved for was 2 theta. 2 theta is what got me the pi over 6 and the 5 pi over 6. So I have to divide everything by 2 to get down to 1 theta. So now theta then equals pi over 12 plus pi k. That's one of my answers. Or 5 pi over 12 plus pi k. Okay. Now, that would be the answer in your first box where it says find all solutions. Then it says in the second box, find the solutions in the interval 0 to 2 pi. Okay, so 0 to 2 pi. Remember here, okay, that 2 pi with the denominator of 12 is going to be 24 pi over 12. So if they want all of the solutions, let me first mark this. This is part A. Okay, if they want all of the solutions like in part B, then the solutions coming out of here are going to be, of course, pi over 12. And you add 24 pi over 12 to that. So this would be, oh, sorry, this is just pi k, not 2 pi. Sorry, I forgot when we divided by 2. So just pi is going to be 12 pi over 12. I apologize. So then if we add 12 to this, this is going to give me 13 pi over 12. That's the two answers coming out of here. And the two answers coming out of here are going to be, of course, 5 pi over 12 and 17 pi over 12. So these would be my four answers. I'm going to put a comma there. For specific answers between 0 and 2 pi. Okay. I forgot here that when we divided by 2, this was just a 1 pi k. Okay, so 1 pi k would be the same thing as 12 pi over 12. Okay, next problem. I have 2 sine of 3 theta minus 1 equals 0. So this is kind of the same vein as what we just did, actually very, very similar. So I'm going to kind of run through it here. So sine of 3 theta equals 1/2. So again, sine is positive in the first and second quadrant. But again, what I'm doing here is solving. So first quadrant, second quadrant. But again, I'm solving for 3 theta. Okay, 3 theta. So in the first quadrant, once again, it's going to be pi over 6 plus 2 pi k. And in the second quadrant, it's going to be 5 pi over 6 plus 2 pi k. Then I have to come through here. Since we were solving for 3 theta, we have to divide everything by 3. This is where it gets a little wonky. Okay. So then my theta equals pi over 18 plus 2 pi k over 3. That doesn't reduce, so you just gotta have to leave it that way. That's one of my answers. Okay. Or 5 pi over 18 plus 2 pi k over 3. Okay. Now, again, it's part A. Now, this 2 pi k over 3, okay? 2 pi over 3, if we're trying to get this to have a denominator of 18, 2 pi over 3 is going to be what? It's going to be 12, right? 3 times 6 is 18, so 2 times 6 is 12 pi over 18. So keep that in mind. Okay, so that's what I'm going to be adding to each of these. Okay, so this was part A. So my part B, where it wants the solutions in the intervals 0 to 2 pi, there should be 6 of them, 3 from each of these. So I should have 6 answers here. So my first answer, of course, is going to be pi over 18. Then I'm going to add 12 pi on top. Okay, so that's going to give me 13 pi over 18. Then I'm going to add 12 pi on top again. So that's going to give me 25 pi over 18. Now, from the next one, my first one is, of course, what we started with, the 5 pi over 18. And then the next one, again, I'm adding 12 pi to it. So this is going to give me 17 pi over 18. Again, gotta love the dead spots. And then add 12 pi again, and we get 29 pi over 18. So these would be my 6 specific answers between 0 and 2 pi. Okay. I can't go any more because if I double 18, I get 36. And if I add 12 to any of those, I'm going to go over 36. So that would be more than 2 pi. Okay. So that was, what was that, number 7? Okay. So 2 more. Okay. This next one's kind of a doozy. So hang with me. We have cosecant theta times cotangent theta minus sine theta times tangent theta equals cosine theta. Now, here's what I did to solve this. I am rewriting everything in terms of sine and cosine. And then I've got to do quite a bit of reduction, a little algebra, and reduce what I can using some trig identities, and then get it down to something that I can solve. So cosecant, remember, is 1 over sine. Cotangent is cosine over sine. Tangent is sine over cosine. Okay, so over here I'm going to have cosine theta over sine squared theta minus sine squared theta over cosine theta equals cosine theta. Now, I looked at this for a little bit when I was solving it myself, and I'm trying to figure out, okay, what's the best approach here? I am going to move this term, this second term, I'm going to move it over because I don't like the minus in front of it. And then I also want to then get common denominators on the right-hand side, which will then give me a trig identity in the numerator, sine squared plus cosine squared, which is what I want. So I've got cosine theta over sine squared theta equals sine squared theta over cosine theta plus cosine theta. And again, I need to get some common denominators here. So I'm going to multiply this by a cosine theta over cosine theta, okay, to get common denominators. So that is going to leave me with cosine theta over sine squared theta equals sine squared theta plus cosine squared theta over cosine theta. Woo! Okay, now sine squared plus cosine squared, what do we notice? Sine squared plus cosine squared equals 1. That's one of our trig identities, right? So now cosine theta over sine squared theta equals 1 over cosine theta. Now, I can actually do cross products, right? So this is going to give me, I'm going to move this away. This is going to give me cosine squared theta equals sine squared theta. Okay, hope you all see that. Cosine squared theta equals sine squared theta. Now, if I pull the sine squared over, then I've got cosine squared theta minus sine squared theta equals 1. Sorry, equals 0. I don't know why I said 1. I think I'm used to the trig identity. Cosine squared theta minus sine squared theta equals 0. This is actually, I was kind of struggling how to solve this. I noticed that this is actually a double angle formula. If you all remember, one of our double angle formulas, we had cosine of 2x equals cosine squared x minus sine squared x. Okay, that's a double angle formula. So I am going to substitute then on the left-hand side. This is cosine 2 theta equals 0. Okay? So that's what I did there. Okay? Substitute in the cosine 2 theta. Now, that means that we've got a couple of choices here. Okay? So this tells me that 2 theta is going to equal either pi over 2 or, oh, and I forgot my plus 2 pi k. So let me do that. Or my second option is 3 pi over 2. Okay. Because remember, cosine is 0. Cosine is your x-axis, so it's 0 at like 90 degrees and 270 degrees. So that's pi over 2 and 3 pi over 2. And again, plus 2 pi k. Not sure why I wrote this one in red, other than I just forgot to change. Okay, now that is 2 theta. So I've got to divide everything by 2 to get that off of there. So that means theta equals pi over 4 plus pi k and 3 pi over 4 plus pi k. So those would be my 2 answers then. Okay, this one was kind of a doozy. Hope you guys got all of that. Last problem. I know this is going on a while, but at least I didn't have to split it up. Last problem for me. I had cosine 2 theta plus cosine theta equals 2. Now, if, again, you remember some of those double angle formulas that we learned in the last section, cosine of 2 theta had like 3 different choices. Okay, one of the choices for cosine of 2 theta was 2 cosine squared theta minus 1. So this was one of our formulas we learned last time. Cosine of 2x equals 2 cosine squared x minus 1. So again, we're going to substitute here. We're going to take this cosine 2 theta and substitute it with 2 cosine squared theta minus 1. And then we're going to keep writing the rest of this and solve it. Okay, so that's 2 cosine squared theta plus cosine theta. If I pull my 2 over to the left, it's going to give me a minus 3 equals 0. Then I can factor it. Now, let me back up a minute. Why did I pick that formula out of the 3? I picked that formula because the other terms, or at least one of the other terms in my equation, was in terms of cosine. So I'm going to pick the formula, the one that fits my problem. I wanted everything in terms of the same trig function, so that's why I picked that one out of the 3. So back to this one now, we are factoring. So I'm going to have a 2 cosine theta and then just a plain cosine theta. Factors of 3, negative 3, I should say. This is going to give me, let's see, a plus 3 and a minus 1. Because then I'm going to have a 3 cosine theta minus 2 cosine theta, which would give me a positive 1 cosine theta in the middle. So solving these, this gives me cosine theta equals negative 3/2, and this sign gives me, this side gives me cosine theta equals 1. Now, cosine theta equals negative 3/2. This can't occur. Why? Because if you remember the range of our sine and cosine function, it goes from negative 1 to 1. So it can't get negative 3/2 is negative 1/2. It can't get there. If you poke that, if you put in the arc cosine of negative 3/2 in your calculator, you get a big fat error. So can't happen. So that one's out. So this one, however, if I solve it, when is cosine theta equal 1? Well, cosine, remember, is your x-axis. It equals 1 at 0. So it's just 0. And if you look back in your directions, it wanted only the answers in the interval 0 to 2 pi. So 0 to 2 pi is all. We didn't have to do the plus 2 pi k stuff. So just 0. Okay? And that's it. That finishes section 7.5.